Good morning. In this video we're going to take a look at the practice problems from section 8.2 of the Systems of Equations chapter. 8.2 deals with solving algebraically. Okay, so you're no longer using your graphing calculator or a grid to graph these equations. You're doing it entirely algebraically. Okay, so that involves rearranging equations and isolating variables. It's fairly straightforward once you get a couple of them done, as it always follows the same steps. So the one we're going to look at today is called substitution for a very good reason. Basically what you're going to do is you're going to take one of your equations and isolate a variable and then substitute it into the other equation. Okay? So we'll go through a few of them, but just before we do that, let's just there we go. So before we do that, let's just take a look at the steps that you'll go through in each case as you solve a system of equations using substitution. So for 1a here, we've got two equations, fairly simple. When you use substitution, generally it's when you have one of your variables with a coefficient of 1. In other words, there's no number in front of it. Okay? That makes it relatively easy to isolate a variable. There are other ways you can solve a system of equations, and we'll take a look at those a little bit later. But if you decide substitution is the way to go, your first step is to isolate a variable. Okay? Now, in this case, you can see that the y in each of the equations is does not have a coefficient other than 1. So in other words, we don't have a number attached to the y in either case. Now, if you look at the first equation, you'll see the y variable is already isolated. No work for you. Okay? So, in the first equation, we're told y equals 2x. Now remember, if we're looking for a solution to this system of equations, as you learned earlier when we actually graphed them, remember, and you can just put this in brackets, remember the solution is a point shared by both equations. And that's very important because it means whatever value y equals, it's the same value as the y value in the other equation. Okay? So if we find that the y value in the first equation is 6, then we know that the y value in the second equation is also 6. Okay? And because of that, we can say that if y equals 2x here, y would also equal 2x in our second equation, and that's where we come to our second step, which is substitution. Substitute the value of your variable into the other equation. So in other words, if we're saying that y equals 2x in our first equation, then we can say that y also equals 2x in our second equation. Notice what I did there. Where I had y originally, I've substituted the value 2x because I know from my first equation that that's what y equals. Okay? Now I know that's a little weird because you're dealing with letters rather than just numbers when you're substituting, but you've been substituting values for variables for years now. Okay? So that's what we're doing. We're saying y equals 2x, therefore we can sub 2x in here. Now look at what this does. What this does is this changes this from an equation that has two variables, an x and a y, to an equation that only has one. And that's really important because if you only have one variable, you can isolate it and find out its value. And that's what we'll do for our third step. Isolate and solve for the variable. Okay, so what does that involve? Remember, you have to simplify both sides and then isolate the variable. So we can simplify the left side. 3x plus 2x is 5x. Looks pretty simple now, right? You want to get your x all by itself, you know what to do. Divide both sides by 5. 5 divided by 5 leaves you with 1x. Negative 5 divided by 5 leaves you with negative 1. We're halfway there. Okay? We now have a value for x. So we know that in our eventual solution, which remember is just an ordered pair, the place where those two lines cross, we know that our x value now is going to be negative 1. Okay? Now, we've done pretty much all the heavy lifting. There's only one step left, and that is substitute the value of your variable into either of the equations. We still got room there? Ooh, we're getting close. Either of the equations and solve. So, we have two equations to choose from here. We've got a simple one, y equals 2x, and we've got a maybe not so simple one, 3x plus y equals negative 5. We know our value of x is negative 1. So, we're going to take that value and we're going to substitute it into either of our equations. I'm going to pick the easy one because I'm lazy. Okay? So, where you see y equals 2x, we're going to substitute the value we found for x. Remember, we found that x equals negative 1, so we can sub that in here and then just simplify. Y equals negative 2, and we're done. So our value for y is negative 2, our value for x is negative 1. Okay? We'll do some more practice with this, but it really doesn't get any harder than that. Okay? Sometimes the equations get a little bit harder, so isolating your variables becomes a little more problematic, but if you just follow these steps, you will never go wrong. Okay, let's try another one. So, we have x plus 2y equals 2 and x minus 2y equals 6. Now, in the case of these two, our first step is just as easy with either of the equations. Okay? Now, I'm going to isolate this one simply because that's going to leave me with no negatives. And if you can avoid dealing with negatives, may as well. So we're going to isolate x in this one. And to isolate x, we simply add 2y to both sides, giving us x equals 2y, right? These cancel to give 0. X equals 2y plus 6. we've isolated our variable x. Remember, because this is a system of equations, we know that this value for x will work for both equations, right? Because it's a point they share. It's that intersection point. So we've done step 1, isolate the variable. Now let's do step 2, substitute the value of your variable into the other equation. Well, here's the other equation. We've said that x is the same as 2y plus 6, so wherever we see x, we're going to substitute 2y plus 6. So my equation becomes 2y plus 6 plus 2y equals 2. Again, notice I've just subbed in 2y plus 6 for my value x. Okay? Now, isolate and solve for the variable. So we're going to want to simplify the left side. We have 2y plus 2y, that gives us 4y plus 6 equals 2. We want to isolate y, so we're going to do the adding and subtracting stuff first. We'll take away 6 from both sides. That cancels, giving us 4y and negative 4. And then finally, we divide both sides by 4, giving us 4 divided by 4 is 1, y equals negative 1. Again, that gives us the y-coordinate of our solution. It's negative 1. Having found a value for y, we can do the final step, which is substitute the value of your variable into either of your equations, doesn't matter which one you choose, and solve. Okay? So, I'm going to sub it into this equation. So, my x minus 2y equals 6, since I now have a value for y, becomes x minus x minus 2, my value for y is negative 1, equals 6. Simplify, minus 2 times minus 1 is plus 2, equals 6. Get rid of that 2 by subtracting 2 from both sides, and I end up with x equals 4. And that's my value for x. Okay? Now, we can verify this equation to make sure that our solution, we can verify the solution by simply substituting it into both equations and seeing if left side equals right side. So let's do that. I know it hasn't asked us to, but it's an important way to check your answer. If you verify every question, you'll always know whether you got the right answer. Okay? So, we've said our solution has an x value of 4 and a y value of negative 1. Now, if we plug those values in, we should be able to verify. So, we have x plus 2y equals 2. Let's sub in these values. So, x is 4, and y is negative 1, equals 2. We simplify this side. 4, 2 times negative 1 is minus 2. And we find that the left side does equal the right side. So, it's verified for this equation. Remember, you have to verify for both equations. Okay? So, for the second one, x minus 2y equals 6. We'll do the same thing. Sub in 4 where you see x. Sub in negative 1 where you see y. Simplify. 4 minus 2 times negative 1 is plus 2. And again you see left side equals right side. You did it. Okay? That's the solution. Okay, fractions. Everybody hates fractions. So, let's do this again. Just a sec here. There we go. Okay, so step 1, isolate a variable. Now both of these are isolated. I'm going to use this one again because it only has positive numbers on the right side. Why deal with negatives if you don't have to? Okay, so we know that y equals 1/2 x plus 1. So that means over here, we can sub in wherever we see y, that value of 1/2 x plus 1. So the variable's already isolated. We move to step 2, and into this equation, wherever I see y, I'm going to write 1/2 x plus 1. On the other side, it's still -3/2 x minus 1. Okay? We can't simplify on the left side, so we'll just drop the brackets. And then, and this is something you learned in chapter 7, if you have fractions, get rid of the denominators, okay? It just makes your life so much easier, okay? So to get rid of the denominator, we're going to multiply everything through by the least common denominator, which in this case is 2, okay? So multiply everything through by 2, that gives us 2 over 2x plus 2 times 1 is 2, 2 times -3 is -6 over 2x, 2 times -1 is -2. This will simplify. 2 divided by 2 will give you 1x plus 2. -6 divided by 2 will give you -3x minus 2. Okay? Simpler, yes? Now we've got to still isolate x. And that means we have to move all the x's to one side. That should probably be your first step, because you want to get x eventually isolated. So we're going to move this -3x. We're going to get rid of it on the right side. And we're going to do that by adding 3x to both sides. That will give us 4x on this side, right? 1 plus 3 plus 2 equals -3 plus 3 will cancel, leaving us with -2. Get rid of the 2. Take away 2 from both sides. Gives you 0 on this side, and you have 4x equals -4. And then finally, you can divide both sides by 4 to give you x. Can you see that? Oh, just barely. X equals -1. So our x value, we now know is -1. We're almost there. Substitute the value of your variable, your -1, into either of the equations and solve. And again, I'm going to go with this one simply because it's got all positives in it, and that always makes things a little bit easier. Okay? So for my last step, I'm going to sub my value for x into this equation, and that will give me y equals 1/2 times -1 plus 1. Okay? Simplify the right side. Y equals, well, 1/2 times -1 is simply -1/2 plus 1. -1/2 plus 1 is +1/2. So my value for y is +1/2. Okay? So again, notice I didn't even have to erase this because we're doing the same steps every time. Okay, this one has different letters. Who cares? It's exactly the same series of steps. Okay, it doesn't matter if it's an x and a y or an a and a b. Okay? So, step 1, isolate a variable. Now, when you look at this, this one's a bit nasty because none of the variables is easily isolated, right? They all have numbers attached. I'm just going to pick this first one, and I'm going to isolate b. Okay? So, in order to isolate b, I have to get it by itself. Now, in this case, it's easier to move b over here. That involves just one step. So if I were to add 2b to both sides, that would give me 6a minus 8 equals 2b. And then to get b all alone, I have to get rid of this 2. I have to divide every term, remember. I have to divide every term by 2. 2 divided by 2 will leave me with b. Minus 8 divided by 2 will give me minus 4. 6 divided by 2 gives me 3a. And now, finally, b is isolated. Okay? Now, since we used this equation to isolate, we have to remember the value for b has to be subbed into the other equation. Okay? So, we'll sub that into the other equation. I just want to make it, well, we'll sub it into the other equation. So 7b becomes 7 times 3a minus 4, right? That's our value for b. Minus 14a plus 26 equals 0. We're a little squished. Simplify the left side. So we're going to distribute that 7 over both of these terms, giving us 21a and minus 28 and minus 14a and plus 26 equals 0. Continue simplifying the left side. You've got some like terms here, right? 21a minus 14a will give me 7a. Minus 28 plus 26 will give me minus 2. Oh, that's so much simpler. Okay? Continuing to isolate a, we'll do the adding and subtracting first. So we'll add 2 to both sides. That gives us 7a equals 2. And then finally, to get rid of the 7, we divide through by 7. 7 divided by 7 leaves us with 1a equals 2 over 7. So we have a fractional value for a. Don't worry about that, okay? Sometimes it happens. We still do exactly the same thing, okay? We take our value that we've found, our value for a, which we've said is 2 over 7. Okay, I'm just going to put a first as part of my solution. In some cases it doesn't matter, but so we'll put it as our first value. So a equals 2 over 7. We go back to our other equation and we substitute the value of a and solve for b. Okay, so 6a becomes 6 times 2 over 7, right? I sub in 2 over 7 where I see a, minus 2b, minus 8 equals 0. I simplify my left side. 6 times 2 over 7 is 12 over 7, minus 2b, minus 8 equals 0. Now, at this point, if you would like, multiply through by the denominator to get rid of it. It just makes life easier. Okay, so we're going to multiply everything by 7. 7 times 12 is 84 over 7. 7 times minus 2 is minus 14b. 7 times minus 8 is minus 56 equals 0. And then 84 over 7 simplifies to 12. So you have 12 minus 14b minus 56 equals 0. Collect like terms. You've got 12 and minus 56. That'll give us minus 14b minus 44. Okay, equals 0. Now we can isolate b. Add 44 to both sides. That gives us negative 14b equals 44. And finally, since you can't see any more of this, we'll just move up here. Okay? So we're going to divide both sides by negative 14. Negative 14 divided by negative 14 leaves us with b. And on the other side, not so simple. We have 44 over negative 14. I'm just going to move the negative up here. Okay? Now, another fraction, but we can simplify this, right? There's a common factor of 2. That'll give us negative 22 and 7, and that's our value. Negative 22 and 7 is our value for b. So, sometimes you will get fractional solutions. Don't worry. Okay? It happens. What are you doing? There we go. Okay, so this next question, we've already done a lot of it. Okay, so it says, Jacob attempted to solve the system of equations 5x plus y plus 20 equals 0 and 2x plus 2y plus 9 equals 0. His work is shown. Okay, so our friend Jacob simply took his 5x plus y plus 20 equals 0 and he isolated y, right? So he subtracted 5x from both sides. That's how you see it comes over to the right as minus 5x. He subtracted 20 from both sides. Again, comes over to the right as minus 20. Okay? So what Jacob said then was y equals negative 5x minus 20. His second step, just like our second step here, was he then subbed the value of y into his equation, right? So wherever he sees y, he's subbed in that value for y of minus 5x minus 20. He then simplifies the left side and gets 0. 0 equals 0. That doesn't make any sense. Uneasy about the result, Jacob graphed the relations and found the two lines intersect at negative 3 and negative 6. I'm just going to erase this, okay, so that we can see the problem. What error did Jacob make? Well, take a look. He used the first equation to isolate y, right? He used the 5x plus y plus 20 to isolate y. And then when he got that value, he made the mistake of subbing that value back into the first equation, where what he should have done is taken this value for y and subbed it into the second equation. Had he done that, he wouldn't have got 0 equals 0. He would have actually found a value for x of negative 3. So the error he made was he subbed his value for y, his value for y into the same equation. So remember that. If you isolate your variable and mistakenly sub it back into the equation you used in the first place, you'll always get both sides equaling 0, okay? And you don't want that because it's not the right answer, okay? Suggest to Jacob a general strategy that he can always use to solve linear systems by substitution. That's the 4 steps that I had right here, okay? I'm not going to write them over again. You can just rewind the video, okay? So those 4 steps: isolate a variable, sub it into your other equation, solve for the value of that variable, and then step 4, once you have the value for that variable, then you can sub that into either of the 2 equations and solve. Okay. Explain how a solution to a system of linear equations can be verified algebraically. Remember, we've done that a few times already. Okay. Sub values of x and y, or a and b, or whatever, into both equations, left side should equal right side. If it doesn't, you've made a mistake. Okay? Explain how a solution to a system of linear equations can be verified graphically. Well, that's easy. Plot your lines on a grid. Or with a graphing calculator. Whoops. And then you can visually check, right? You can check where those two lines cross and see if it's the same as the answer you got. Okay? So check coordinates of intersection. Describe an advantage to verifying a solution using each method. You know, it really just boils down to what you're comfortable with. Okay? A grid method involves graphing. You have to have a grid, or you have to have a graphing calculator, and that involves isolating your variables. Okay? Whereas the algebraic method, some people don't like algebra, they don't like plugging in, substituting values for variables, although if you aren't very good at that, that's going to make this chapter very, very difficult. Okay? So we're just going to say personal preference. I prefer doing it algebraically just because I'm comfortable with that, and that means I don't have to mess with a calculator or have any graph paper handy. Okay? This last problem is actually kind of beyond what I would expect you to be able to do. So we're going to skip number 4. We will come back and we will do many, many word problems. Okay, but this is not a place to start. This is much more difficult than it needs to be. Okay, so that's it for today. The next lesson we will do some word problems that involve using substitution, and we'll go over just a basic series of steps that will help you with word problems in this chapter. Anyways, have a lovely day. See ya.